Hello everyone! In this video we'll talk a little bit about linear interpolation. Linear interpolation sounds very complicated, but it's actually very simple and it's very useful. So here we have a little cat and he wants to reach the heart. And here we have a previous code from a previous video where it is moving towards the heart at a constant speed, which we have been able to adjust. And so moving in this way is something we can do. But sometimes we want to be able to control exactly how long it takes us to reach our objective. And so whenever we have, we will have something that is somewhere, and we want it to be somewhere else, but we want it to be somewhere else at a specific time, what we can do is use linear interpolation. So let's just look at the code that we have here. We have two vectors. This is the target and the start position. Whenever I press the reset button, the start vector is set to the player's position, and the target is randomized, and the heart's position is set to the target. So as you can see, every time I press the reset button, the heart changes position to a random place. So what is linear interpolation? In linear interpolation, we want to go from one point to another. So let's call this, let's say this is A and that this is B. And so instead of specifying the specific times, we want to use a parameter that we will call lambda. And so we want it to be that when lambda is equal to 0, we are at A. When lambda is equal to 1, we are at B. Where lambda is equal to a half, we're halfway between A and B, and so on. So for example, when lambda is equal to 1/4, we want it to be on the way from A to B. And so the first question is, how do we get lambda? And the idea is that if we look at time, so this will be my t0, this will be my t end, so the beginning and the end, and we want lambda to be 0 here, and lambda to be equal to 1 there. And so what we can do is we can say that lambda is going to be equal to, well, of course, at some specific time t. The question is, what is lambda equal to? And so lambda will be equal to t minus t naught divided by t end over t naught. And so what is happening is that when t is equal to t0, this thing is going to be 0, so we're here. When t is equal to t end, this is something divided by itself, so we have 1. And this is growing linearly, so it will just smoothly go from one end to the other. Okay, so this is how we get lambda. But how do we get now the position from A to B? It's going to be quite similar, but in the opposite way. And so now my position, which is going to be P, is going to be equal to, it's going to be the start position, which is A, and it's going to be our end position, which is going to be B. We want to multiply them by something. And so we want so that when lambda is equal to 0, we have A, and when lambda is equal to 1, we have B. So what I can do is I can multiply by 1 minus lambda, and by lambda here. And so what is going to happen that when lambda is equal to 0, this is 0, this is 1, so we have A. When lambda is equal to 1, then now this is 0, but this is 1, and so we have just B. And as we change lambda, it will go smoothly from A to B. But another way to write this is going to be, well, A plus B minus A times lambda. This is just expanding and rearranging. And we can see that we start at A and we go from A to B, because when lambda is equal to 1, these A's will cancel out and we get B. But when lambda is 0, this is just non-existent. And so this is the formula that we're going to use. Let's see how that works. So first we will need some time parameters. So that will be my time parameters, which are going to be floats. I'm using Godot, but this works on any engine, on any programming language you use. I'm going to say my big T is how long it takes for each to reach the objective, which is going to be just, let's say, 2 seconds. And now what we're going to do is, well, let's just get rid of all of this. Let's advance time by saying T plus equals delta. Delta is the time that has passed since the previous frame, so this is the best way to advance time. And we also want to reset time. So T is going to be equal to 0 whenever we press the reset button. And then we want to find this lambda. And so in this case, it's going to be, it's a bit simpler because T0 is 0. So it's just going to be T divided by big T. But we're doing interpolation. So what happens when T is bigger than the end of time? In this case, if we didn't change the formula, it will just continue going past the objective. So what we're going to do is going to clamp. And so this is going to clamp lambda between 0 and 1, so that it cannot go beyond 1. If we go beyond 1 or beyond 0, that's what we call linear extrapolation, because we're going beyond the limits of our 2 points. So now that we have lambda, and we do need to make it a variable, we can now find what the player position should be. So the player position should be equal to the target position, sorry, the start position, plus the target minus the start position times lambda. And so if we reset it and we set it to running, it's going to reach, and it's always going to reach the heart in 2 seconds, no matter how far or how close the heart is. So we go 1 and 2, 1 and 2, 1 and 2. And so it is going to be reaching that. And now we can adjust this, for example, to half a second. And now it's going to be zooming around the screen because it's only taking it half a second to reach the objective. Doesn't matter how far, doesn't matter how close. It's always going to reach it in exactly the amount of time we want it to. And so linear interpolation is very useful. Whenever you have something that is one way and you want it to be a different way, but you don't want to instantly get to that different way, you can just use linear interpolation like this. One other thing is that linear interpolation is very common in game development. So we often have functions that help us do linear interpolation. In the case of Godot, it is Lerp. And this comes from, we write linear interpolation. For some reason, we are taking this L and this ERP to create the Lerp function. Unity, for example, has the same, but it's like with capital letters. And so the Lerp function will just take the start, the target, and the lambda. So let's just replace it. So that's my Lerp, which is going from the start to the target with a lambda. We reset it, and it is working nicely. So this function is going to be very useful, and you might want to start using it a lot because it's super useful. Whenever you want to move something from one place to another, you can do it with this.